Hello everyone. In this video, I'll be discussing about clustering and application of k-mean clustering using Python. So let's begin with definition of clustering. So clustering is an unsupervised machine learning technique used to group similar data points together. It's like sorting objects into categories based on their shared characteristics. Now, what do we mean k-means? So k-means is a clustering algorithm used to segment data points into a specified number of clusters. It groups data points based on similarity, allowing us to identify patterns and relationship within unlabeled data. K-means is widely used in applications like customer segmentation, images compression, and anomaly detection. And here we dive into code. Let's understand how K-mean works. So here are the first steps how K-mean works. First we have is initialize centroids. So in this step, we start by placing k centroids at the random points in the data. Second step we have is assign data points. So in this step, each data point is assigned to the nearest centroid, forming clusters. And third step we have is update centroids. So in this step, we move the centroid to the mean of the points assigned to each clusters. Fourth and the last step we have is repeat. Steps 2 and 3 are repeated until centroids are no longer moved or we reach a maximum number of iterations. Then third we have are some applications of k-mean clustering. First we have is customer segmentation. So in this application, companies use k-mean to segment customer based on purchasing behavior, demographic information, and preference to the offer target marketing. Second application we have is image compression. In this, k-means can compress images by reducing the images of colors in an image to the set number of clusters, making the image smaller without significant loss of quality. Third application is anomaly detection. By identifying clusters of normal behavior, k-means can flag data points that don't fit into any clusters as anomalies or outliers. Fourth application of k-mean clustering is market segmentation. It helps to dive a broader market into subsets of consumers with similar needs or characteristics for personalized marketing. So these all were the applications of k-mean clustering. Then we have is advantages of clustering. So advantages of clustering are first, unveiling hidden patterns. In this advantage, clustering helps us to identify patterns and structures with data that might not be apparent through simple visualization or statistical analysis. Second advantage we have is data reduction and simplification. By grouping similar data points, clustering reduces the complexity of large data sets, making them easier to analyze and interpret. There are several disadvantages of clustering as well. First is sensitive to initial conditions. So in this, some clustering algorithms like k-means can be sensitive to the initial choice of cluster centers, which can affect the final clustering result. Second, we have is interpretation challenges. In this, interpreting the meaning of clusters can be subjective and may require domain expertise. So these were advantages and disadvantages of clustering. And here is the code regarding clustering and k-mean clustering. And this is the output of the code. In this various clusters are forms, as you can see. And then we have the explanation for the code. So in the code previous, we have data preparation. In data preparation, we generate a synthetic data set using make blocks for demonstration, which creates cluster of data points resembling customer segments. Then second step we have is standardization. In this, we scale the feature to standardize the data. This is an important because the k-mean is sensitive to feature scaling. Third step we have is elbow method. In this, we use the elbow method to find the optimal numbers of clusters. The elbow point in the inertia plot suggests that the best case k by showing where adding more clusters doesn't significantly decrease the inertia. And fourth we have is k-mean clustering. In this, once we decide on k, say 4 clusters, as was seen in the output, there are 4 clusters. We apply k-mean to assign each data points to a cluster. Then final we have is visualization. So we plot the clusters along with the centroids showing distinct customer segments. Each color represents a different segment with red crosses marking the centroids. So here is the red cross that marks the centroid. So this was all about clustering and k-mean clustering. I hope you liked the video.